Hi there. Welcome back to our next session on multithreading and synchronization in Java. In this session we would discuss about multithreading, its advantages, lifecycle. We would then learn how to create thread, implementing Runnable interface, thread scheduler, thread priority, Daemon Thread, garbage collection in Java, synchronization, and other topics. First of all, we would discuss about multithreading in Java. Multithreading in Java is a process of executing multiple threads simultaneously. Thread is basically a lightweight subprocess, a smallest unit of processing. Multiprocessing and multithreading, both are used to achieve multitasking. So what is the advantages of multithreading in Java? A thread can perform many operations together, saves time. Threads are independent, if exception occur in a single thread. It doesn't block the user because threads are independent. It has simplified coding of remote procedure calls and conversations. In some applications it is easier to code different remote procedure calls and conversations in separate threads than to manage them from the same thread. And it has reduced number of required servers, sub-process share common memory space, utilize the maximum CPU time to keep the idle time minimum, and context switching between the threads takes less time than process. Now let's talk about thread. A thread is a lightweight sub-process, a smallest unit of processing. It is a separate path of execution. Threads are independent. If there occurs exception in one thread, it doesn't affect other threads. It shares a common memory area. As shown in the figure, thread is executed inside the process. There is context switching between the threads. There can be multiple processes inside the OS, and one process can have multiple threads. Now let's discuss about the life cycle of a thread in Java. A thread can be in one of the 5 states. According to Sun Microsystem, there is only 4 states in thread life cycle in Java: new, runnable, non-runnable, and terminated. There is no running state. The states of a thread are new, runnable, running, non-runnable or blocked, and terminated. See the diagram and make note of the life cycle of the thread. New. The thread is in new state if you create an instance of thread class but before the invocation of start method. Runnable. The thread is in runnable state after invocation of start method, but the thread scheduler has not selected it to be the running thread. Running. The thread is in running state if the thread scheduler has selected it. Non-runnable or blocked. This is the state when the thread is still alive, but is currently not eligible to run. Terminated. A thread is in terminated or dead state when its run method exits. Now let's discuss about creating a thread. There are 2 ways to create a thread. By extending thread class, and by implementing Runnable interface. We will see the both ways with program. Before that, let's see some of the constructors of thread class. You can see the constructors on your screen. Let's see the first way of creating thread in Java by extending thread class. Create a class and extend the thread class. Write the public void run method and give your message to be printed. Call the constructor of your class in main method and start the thread. You can see the program on your screen and pen it down. Save your file and run it. You can see that the thread is created. Now let's see the second way of creating thread in Java by implementing Runnable class in Java. Runnable is an interface and thread is the class that implements Runnable interface. You can directly extend the thread class or implement the Runnable interface. See the program, where we are implementing Runnable into our class. It is almost same, we are writing the run method body in our class. Save the file and run it. Output would be the same as first program. Thread scheduler in Java. Thread scheduler in Java is the part of the JVM that decides which thread should run. There is no guarantee that which runnable thread will be chosen to run by the thread scheduler. Only one thread at a time can run in a single process. The thread scheduler mainly uses preemptive or time slicing scheduling to schedule the threads. Thread priority in Java. Each thread have a priority. Priorities are represented by a number between 1 and 10. In most cases, Thread Scheduler schedules the threads according to their priority, known as preemptive scheduling. But it is not guaranteed because it depends on JVM specification that which scheduling it chooses. You can see the program and try to do it while watching this video. You can pause it. In this program we are setting the priority of threads according to the sequence of its execution. Now let's talk about Daemon Thread in Java. Daemon Thread in Java is a service provider thread that provides services to the user thread. Its life depends on the mercy of user threads, that is, when all the user threads dies, JVM terminates this thread automatically. There are many Java daemon threads running automatically like GC, Finalizer, etc. You can see all the detail by typing the jconsole in the command prompt. The jconsole tool provides information about the loaded classes, memory usage, running threads, etc. See the program of Daemon Thread. Write the program as it is shown. Points to remember for Daemon Thread in Java. It provides services to user threads for background supporting tasks. It has no role in life than to serve user threads. Its life depends on user threads, and it is a low priority thread. Now let's talk about garbage collection in Java. Garbage collection is process of reclaiming the runtime unused memory automatically. In other words, it is a way to destroy the unused objects. See the figure to understand the garbage collection in Java. So what is the benefit of garbage collection? See the advantages of garbage collection. It makes Java memory efficient because garbage collector removes the unreferenced objects from heap memory, and it is automatically done by the garbage collector, so we don't need to make extra efforts. The GC method is used to invoke the garbage collector to perform cleanup processing. The GC method is found in system and runtime classes. See the program to do garbage collection explicitly. If you don't run GC method, compiler does it for you automatically. Write down the program. Thing to be noted down. Garbage collection is performed by a daemon thread called garbage collector, GC. This thread calls the finalize method before object is garbage collected. Now let's talk about synchronization in Java. Synchronization in Java is the capability to control the access of multiple threads to any shared resource. Java synchronization is better option where we want to allow only one thread to access the shared resource. You can see the figure on your screen. It describes the mechanism behind the synchronization in Java. Types of synchronization: process synchronization, and thread synchronization. We will discuss about thread synchronization in Java. Process synchronization is for operating system. There are two types of thread synchronization in Java: mutual exclusion, and cooperation. Mutual exclusive helps keep threads from interfering with one another while sharing data. This can be done by three ways in Java: by synchronized method, by synchronized block, and by static synchronization. Now let's see the synchronized block in Java. Synchronized block can be used to perform synchronization on any specific resource of the method. Points to remember for synchronized block. Synchronized block is used to lock an object for any shared resource, and scope of synchronized block is smaller than the method. Let's see the example of synchronized block in Java. Open your notepad and write the code as given. In this example there is class called table that has synchronized block, and two thread classes that are passing table class in their thread. Create a public class that contains main method and create the only one object of table class. Call this object into thread constructors. Save it. Open the command prompt and move to the folder and compile the code and run the program. You can see the output. First of all, it will generate multiples of 5, then multiple of 100. This is synchronization in Java. Now let's talk about static synchronization in Java. If you make any static method as synchronized, the lock will be on the class, not on object. Suppose there are two objects of a shared class, for example, table named object1 and object2. In case of synchronized method and synchronized block, there cannot be interference between T1 and T2, or T3 and T4, because T1 and T2 both refers to a common object that have a single lock. But there can be interference between T1 and T3 or T2 and T4 because T1 acquires another lock and T3 acquires another lock. I want no interference between T1 and T3 or T2 and T4. Static synchronization solves this problem. Deadlock in Java. Deadlock in Java is a part of multithreading. Deadlock can occur in a situation when a thread is waiting for an object lock that is acquired by another thread, and second thread is waiting for an object lock that is acquired by first thread. Since both threads are waiting for each other to release the lock, the condition is called deadlock. Inter-thread communication or cooperation is all about allowing synchronized threads to communicate with each other. Cooperation, inter-thread communication, is a mechanism in which a thread is paused running in its critical section and another thread is allowed to enter, or lock, in the same critical section to be executed. It is implemented by following methods of object class: wait, notify, and notify all. The point-to-point explanation of the diagram is as follows. Threads enter to acquire lock. Lock is acquired by onThread. Now thread goes to waiting state if you call wait method on the object. Otherwise it releases the lock and exits. If you call notify or notify all method, thread moves to the notified state, runnable state. Now thread is available to acquire lock, and after completion of the task, thread releases the lock and exits the monitor state of the object. Hope you enjoyed this session. In our next session we will talk about regular expressions and inner classes in Java. Till then, take care, thank you.